All right, so for those who don't know me, my name is Craig Smith. I unfortunately haven't been to REcon in a bit. I think the last time I was here I did like a talk on code obfuscating virtual machines, and I took another job and started my own business, which ate up all my time. During that time I also helped found a hackerspace in Cincinnati. That hackerspace is called Hive13, which is up there. Recently we started a group called Open Garages for hacking cars. And the reason being is because previous year I was involved in a project that was really, really cool. There was a group of kids who were picked up from high school and from some colleges, and they were just selected due to academics. They didn't have any kind of prior knowledge in hacking, they didn't have any prior knowledge in reverse engineering or cars or anything of that nature. So it was basically this week-long hackathon where the kids were put on this thing where they're there all day long. They had no internet, no cell phone access. Some days they were there like 24 hours a day. And during this time, they were taught the basics. They were taught, intro to pen testing, intro to CAN bus, intro to electronics, that kind of stuff, and really just released onto cars. They were broken into 4 groups. Each group had a vehicle, same make and model for each one. I think it was just kind of an experiment to see what would happen at the end of the week if you took 4 intelligent groups of kids and unleashed them on a car. It was actually really, really impressive. I was brought in as kind of like a mentor role, which basically just meant tell kids oh, I know you've learned from books and teachers, but now ignore all that. There's no books for this stuff. We're going to totally think outside the box. That means you just have to make stuff up, see what happens, and act on it. The hacker way of doing things. Watching them was really, really cool, and they came up with some really, really good exploits for these vehicles, and a lot of them I didn't really think they'd truly be able to pull off in a week, but they're really good at it, and I'd love to tell you about them, but I can't. This is actually one of the bigger problems I think with this research is they're all done in individual silos, kind of like you mentioned, where people are doing research right now, but it's just not really shared because of certain NDAs. So they're all private research. They do research for automotive industries, and it's great that people have been looking at the security of vehicles. I mean, it's a very useful thing for us to have. The problem is when you give a company unlimited time to fix a problem, it tends to be if the problem will be fixed, because the researcher can't expose it. And for the most part, it's not like software where some other dude down the street is just going to release it in a week if you don't fix it soon. So they can sit on for a very long time, and unfortunately, we're driving these vehicles they can sit on. And one of the reasons there's such a big barrier is because some of the tools, kind of like was mentioned before, is that they're relatively expensive. I mean, a good tool specifically developed for reverse engineering and a good scanner for it can cost about $5,000. That's not super expensive, but it's more expensive than just somebody who's casually wants to look at their vehicle. And also these protocols that are out there. There's OBD, which is kind of a generic protocol. It basically is a standardized thing. You can get an app for it. And all it's really doing is just telling you that, okay, it's like SNMP, if you guys know networking. So there's an ECU, it's an engine control unit, as we mentioned. And what will happen is maybe it sets the tachometer to 65 miles per hour. Then OBD spits out back and says, oh, by the way, I set this tachometer to 65 miles per hour. Which is great, except for the fact that if it tells you, oh, by the way, I set this tachometer to 65 miles per hour, and it didn't. Where do you go to look to see why it didn't do that? So this is the problem with normal mechanics have, is that when they get together and they plug in their device, they say, oh yeah, the engine light was on because of this problem, but they can't look at the actual packet to see what may have caused this problem. And it's not that this stuff is completely secret. They do sell this information, but it can cost upwards of 25 grand for these proprietary codes, and they are different for each make and model, like we discussed. So really only dealers can kind of get this information. Security engineers usually can't. Mom and pop dealerships usually can't. And that's one of the biggest problems, and that's one of the reasons I created Open Garages. It's pretty much to kind of address this issue. And recently what happened is, at the beginning of this year, I reached out to the mailing list for the Hive, and I said, hey, who wants to hack some cars? And everybody's like, yeah, let's do that. And so we create this group, and the thing that really surprised me is the first time we had this group, and a bunch of people showed up, I was the only hacker that showed up. There was mechanics that showed up. There was people who do race cars showed up. There was some lady who had a car where in California, they released a firmware update that's mandatory in California because of some lawsuit. but it's nowhere else, and so she can't get the update because it's only free there. And I realized that with this diverse group, there's actually a much bigger problem. Nobody can really look into these things to get these things fixed. So we decided, okay, well, let's sit down, make a list of all of our issues, and see if we can address them. First thing we want to address is documentation. So with documentation, I don't really mean documentation on CAN bus. There's a decent amount on the protocol. I mean like when you find something that changes the tachometer, rolls your window down, or whatever, there needs to be a website you can go to, punch in this CAN information, like, oh, on my Ford Fusion 2011, this rolls down the driver's side window. There needs to be somewhere you can put that information in, and a place you can download it in a set format. So you can use it in my tool, you can use it in your tool, you can use whatever tool you have. Also a way of validating people's stuff. Very similar to when people were releasing like open Wi-Fi networks. By the way, a quick thing about this quote. I was actually in a group of developers, and I was sitting as the security guy. And they were bitching online to this company who made this big enterprise software. And they had this huge documentation of APIs. And they're like, hey, you know, we've been working on this API for weeks, and it just doesn't work. Your software's broken. And they responded like, our software's not broken. It works as designed, just not as documented. Which I thought was kind of amazing. It's kind of like, read the fucking source, even though we didn't give you the source. And I kind of think that's how CAN bus is. So the other piece of documentation is when you're working with these teams. So you really need a methodologies doc as well. Because it may be like, you know, maybe you know software, and your friend wants to hack cars too, but he knows like, I don't know, Arduino. Nobody's a mechanic. So you kind of need some bootstrapping stuff to kind of let you know like, oh, here's the basics of a car. This is what an engine control unit is. You know, like, here's how you make an ECU test bench. You know, maybe for the things we're doing, this is actually really dangerous. Maybe you shouldn't use your car. Maybe you should rent a car. Pay the extra insurance on this one. And so we kind of need some bootstrapping docs. Because it's such a varying group of people who want to get into this. It's not just hackers, it's not just mechanics. We kind of need some other bootstrapping docs to fill in your group's extra area that you're missing. So speaking of ECU, this is an ECU test bench. They're really small, just because there's not much to them. This is just an ECU. A guy at the Hive named Steve put this together. These you can get from a junkyard for like $100, $150. This is the engine control unit. It's the motherboard, essentially, of your computer, the brains of it. All you do is you look at the part number on the back, and you can find the wiring diagram, and you attach power. This is ATX, just a basic switch is attached, and a CAN port. This is much nicer for software guys to work on than actually attaching to a car half the time. You get a lot of data out of it. It works with scan tools. A scan tool is kind of like what mechanics will use to, you know, read the VIN number, figure out what kind of car it is, how many cylinders it should do, a bunch of stuff like that. They'll work on these kind of test benches. They're good for software development because you can kind of see all the packets, do things like data visualization, which you kind of saw, where it was kind of like, as opposed to just getting a list of packets, because it's just so much data. You'll sort by arbitration ID in this case, and what's changing. That's a much better way of looking at the data. This is really good to test your software out without running on an actual car. What it won't do very well is it won't like work on individual packets. So if you want to roll down that window, if you want to unlock the car door, this one's kind of bad because there's no car. So like in the scan tool, the engine light's always on these kind of things. But like, you know, as far as like doing your data visualization, these are fine. Pretty cheap to build yourself. Now at the hackerspace, we didn't really have the ability to spend $5 grand for everybody who wanted to hack a car. Plus, we're a hackerspace, so we like to make things. And we like to make open source stuff. So we decided we'll design an open source board. We needed one that could do specifically what we wanted. We want it to be cheap to buy, but at the same time, expandable. You know, not cheaply made kind of deal. And once we had that, we're going to need some open source software with it. We're going to need it to be basically, the firmware needs to be open source, and we need to work with multiple users. One issue that I had during that like hackathon thing is that with each individual student, we were using Y connectors for each scanner, or each sniffer, I'm sorry. And after 6, the whole car battery would just die. It just drain it out. So we doubled up. We only put like 3 people per car. And none of these tools are really meant for more than one researcher to work at a time. So we want some support for multiple users. So far, we have this thing called, this is the CAN in the middle device, the one on the lower right side. It's really tiny. It's actually, this is the size of the board right here. What it basically is, it's a STM32F417, which is a ARM 168 megahertz Cortex M4, I believe. And what it basically has 2 CAN transceivers on it. That thing at the end, that RJ45, is not network. It's very similar to the data caca. It's just data I/O ports. So like it can either plug directly into a CAN bus and do one CAN sniffing, or you can splice a line, and it works as a bridge between packets coming in, packets going out. You can firewall them. You can change them in transit. Hence the name CAN in the middle board. So you can have half your car think one thing, the other half car think the other thing. It has a bunch of stuff for expanding. So this board, like the processor on this thing, has a built-in FPU, has built-in crypto. Even though the CAN really doesn't use much crypto, once these start coming out, they might start. So we want to put that in there just in case. Pay the extra $1. There's a SD card on there. Everything's broken out. Broken all the things. The MCU on the bottom there is, we're not using that. You can just plug it in and do whatever you want with it. The thing by the RJ45, you can wire tap onto what's going in and out of the machine if you want to. The button's just there in case you want a button. Things of that nature. And the other board that's up in the corner, that's actually just a dev board. And it comes with a program and a program the dev board. We just wire tapped off of that one to program our board. So that's all that's going on in that picture. So we also made the Cannabis server. Now the Cannabis server isn't required for the CAN in the middle. It's actually a separate thing, but we did need it. This is kind of like the GUI piece. Very similar to what was just presented. It's our solution to the issue of multiple developers. So the way this works is a client-server model. So you have a server piece. You can attach the CAN middle board or any other board it has a driver for. And we're just slowly adding drivers, mainly open source first. And eventually we might add some proprietary drivers. But the way it works is you connect in, currently via incurses, and you see all the cards you can hack, which are really just all the CAN buses plugged into the server. You're also in a lobby interface, like a game lobby, and you can chat with other people that have connected in and say, like, oh, which card I want to hack today? And you pick one, and you jump into it, and it creates a hack session. And then once you're in your hack session, first person in that little channel, it works like IRC, first one in that channel decides to sniff, the server does all the sniffing, and it records everything coming off the CAN bus. And if you set your filters for your arbitration ID or whatnot, you'll be streamed that filter, but the server's still receiving it. And the benefit of this is that if the guy next to you wants a different filter, he can still get that. You're not really using up any more processor, you're doing one sniff. If you inject packets, it adds metadata. So it says, hey, Craig injected this packet. So on your end, you can see, well, the reason why the door unlocked is Craig just sent that packet. There's an identifier to who did what, plus it's in the log, which is really nice. The other benefit, it has a chat system in the hack session itself. So one thing we found out is that when, the first thing you tend to do is you do really simple hacks. Like you want to turn the turn signal on, or you want to roll down the window. So what happens is somebody's usually sitting in the car, somebody's outside the car with a laptop, or somebody maybe in the passenger seat, and somebody will just yell at the person in the driver's seat, like, hey, roll that window down again. And it can be a little irritating. So now we have it so you can just chat and just say, like, hey, roll the window down. Yeah, I just did. And now it's in your log. So between rolling window down and rolling windows done, the packet probably happened within that, which is really, really useful. So since we just started this year, there's still a lot of work that needs to be done. I mean, we've made a decent amount of progress. One thing that I really want to encourage you, if you're interested in any portion of car hacking, be it just for, it doesn't have to be like the main reverse engineering piece. It could be like, oh, I want to go to Burning Man. I want to do all these cool lights off of my CAN bus. Perfect. We need people like you. And all we really need is, if you're interested at all, go to Open Garages and sign up for the mailing list. You can lurk, you can post some stuff. If you're really interested in hacking, we recommend creating what we call a VRL. This is a Vehicle Research Labs. It's just a title we created. And the idea is that, okay, I'm in North Carolina, and I'm going to, I really want to hack my car for whatever the reason is. And so you basically just sign up a VRL on Open Garage's site and say, like, oh, here's a VRL. We're going to meet, pick a date, like the first Saturday of the month on IRC or at this bar or some coffee shop, and we're going to discuss this stuff. And it kind of makes you go out and schedule a time to actually make some progress, but also gives a way for other people to find you nearby. It definitely helps to have physical people working on these things near each other because it's an actual car. And then also, if you know someone else is going to show up, you're more likely to actually make some progress on this type of stuff. So it's just a way of just identifying where you're at. The piece that we really need help on, that we haven't started on at all, is the research portion. So once these boards come out, these boards, The one I showed was revision 2. Revision 3 came in to Cincinnati on Wednesday of this week. Assuming everything solders up and works well and all the tests pass, that's the one that's going to go to the pick and place machine. And that one will cost about $100, fully assembled, that you can buy. And once those are there, we have some software to pull some stuff off that's reliable, we're going to have to start reverse engineering the packets. And so we're going to need some time to figure out, like, okay, with this make and model of car, this is what we're seeing, and share that type of info. We also need a website to keep this stuff. We haven't actually built that part yet. So if people have like suggestions of a certain framework they think would be ideal, that maybe there's already some work done that would work really well for this, let us know. Not today. Don't do it during the comments. Just go to the mailing list and post it there so everybody can kind of see it. And the only other thing is we do need some more work on some of the coding. Once the board's totally finalized, I'll get the firmware done. I'm pretty much the only one working on coding right now. So CAN bus, why it works, and it's proof of concept. It works on, I think, the ELM crappy chipset right now. But like, I'm moving it to Google Go. And so mainly for the concurrency reasons. And the problem with this is that I'm learning Google Go as I write it. So it's a little slow. And I'm hoping that actually what we'll be able to do is use WebSockets. We'll see. Because then we don't need to worry about different people's clients, and you can do it on the mobile and whatnot. And, hack your phone remotely via your mobile device over a firewall from Seattle, hacking a car in Cincinnati would be awesome. So that's kind of where we're going with this. So that's pretty much the presentation for open garages in general. So I'd like to open it up to just any kind of questions that we'd have with the hot wiring a car or just general things about the devices and whatnot.
Yes and no. I mean, the easiest way to do that is just to leave something.
Can you hear me?
There you go.
The easiest way to do that is going to be just to leave something in your OBD2 port, obviously. In terms of persisting it on the system, the guys at CAESS, the AutoSec guys, were able to like reflash ECUs like without a proprietary scan tool. We did not make it that far in our project. So the answer is it's possible, but I don't really know how.
It's modifying the firmware if you want to stick persistent. Oh, the question is people dump the firmware? Yeah, all the time. The thing is, like, a lot of times you do need special codes and whatnot to dump firmware on ECUs and whatnot. You can either pay for those, you can get them off, like, aftermarket type stuff, works really well for that. A lot of mom and pops actually have to resort to that. That's actually their main way of doing business. But because they can't really get the actual packets for a lot of these things, they buy gadgets from China and whatnot that have certain codes in them for that make and model. And it's a lot cheaper, but I still wouldn't say it's cheap. A lot of them still have like subscriptions and whatnot to pull firmware and upload firmware. Some licenses are like you can only upload 7 times to your ECU and it's gonna it's gonna quit. So
it also varies a lot by the manufacturer. So some are subscription based, and you have to pay like I know for BMW it's like 7,000 starter and then 1,000 every time they release an update. And every time they release an update, like 2 months later, you can buy it from China, that kind of thing. But it's not necessarily a one-time cost.
And I want to make that part free.
Over there. Like how many different segments? It totally depends on the manufacturer, how nice your car is, that kind of thing. You'll very commonly get access to the high-speed and medium-speed cans through the OBD2 port, but there may be there'll be like a node that also sits on a LIN network, which is only responsible for some subset of engine functionality, and then we'll report that as a single ECU on the CAN bus. That's one of those things where there's not a whole lot of information. There's a lot of sort of different implementations by different manufacturers. You have to look at the wiring diagram for a specific car to really know.
Yeah, we just mentioned, because I forgot to mention in the talk, this board also has SPI, and then we'll support up to 6 CAN buses out. We have another board designed but not printed yet. I can add 4 more CAN bus boards if you need to. That'd be for one vehicle. Like to hit the infotainment bus, or sometimes there's a high-speed CAN bus and a low-speed CAN bus, and that kind of stuff.
There's also like single wire CAN, which is cheaper. So they'll implement some functionality on single wire CAN just because it saves them some money. All the way in the back, yeah? Have we seen any use of CAN authentication schemes? The main thing that I'm aware of is stuff like ignition, or keyless entry. There's very frequently some authentication that goes on.
It's usually like a rolling seed kind of deal. I can't comment. Maybe you can.
I don't know. Sorry. Any other questions? Comments? Concerns? All right, on to the next presentation. Thank you, guys.